All right. So when we're talking about antiderivatives, remember that we're using what we had the other day, what's called an integral from a to b of f of x dx, right? The reason it's called an antiderivative is because technically we will eventually be going from the derivative that's in here to the original, or the antiderivative. Okay? Today, though, is just an introduction. I want to talk about some of the rules. So, rule number 1. Rule number 1 is order of integration. When I say order of integration, we always like to have our smaller, our lower bound at the bottom. If for some reason, go back this way a little bit, if for some reason your original integral has it going from b to a of f of x dx, then in order to flip these the right way, we're just going to put a negative in front, or multiply the whole thing by a negative, which flips your bound, your lower bound or lower limit, to your upper limit of f of x dx. Rule number 2. Yeah. Let's put a negative in front of the whole thing. We'll be good. All right. Rule number 2 is the 0 rule. 0. If I have an integral that goes from a to a, and really that means my lower bound and my upper bound are the same of f of x dx. If my lower bound and my upper bound are on the same line, how much area is there? None. So this equals 0. Makes sense, right? All right, now we're going to do the sum and difference. Sum and difference. If I have an integral from a to b of f of x plus or minus g of x, so I actually have like 2 terms in there, 2 functions in there, right? I can actually write these as 2 separate ones if I want to, and say I have the integral from a to b of f of x plus or minus the integral from a to b of g of x. Let me get this out of our way. So I can actually separate them. Yeah, you'd have the dx. Technically, I should write this one like this with dx at the end of that. And then the dx, of course, is kind of like it distributes into both of them. So it's the antiderivative you'd be doing of each one. Bless you. So this is another important rule. This is the additive rule. Additive. All right. This one says if I have an integral from a to b of f of x dx, and I'm adding it to an integral that goes from b to c of f of x dx, I can actually do an integral that goes all the way from a to c of f of x dx. And last but not least, I better do the constant rule. And last one is constant. Constant. If I have an integral of a to b of, let's say, I have k, whatever this constant is, I'm going to call it k today, of f of x dx, I can move that k out in front of the integral. So k times a to b of f of x dx. So we're going to practice using some of these rules today. Any questions so far? All good? All good? All right. So, example number 1.
Oh, wait, can you go back?
Yeah. At the bottom. Yeah. That's good. Are you good?
Yeah, I'm good.
Okay. All right, so here is example number 1. First thing I'm going to tell you, I have an integral that goes from negative 1 to 1 of f of x dx. I'm going to tell you that equals 5. And then let's say I have an integral that goes from 1 to 4 of f of x dx. And I'm going to tell you that integral from 1 to 4 equals negative 2. Huh? So what I want to know is, can we find, let's see, let's do this one. How about the integral from 4 to 1 of f of x dx? Can we evaluate that one? So, yep, we've got to make it negative to flip those bounds, right? The first thing we do would we flip this and make it a negative. It goes from 1 to 4 of f of x dx. So that means I have a negative, and this 1 to 4 f of x dx equals negative 2. So my final answer would be a negative 2 is 2. That's it. What if I had the integral from negative 1 to 1 of 3 f of x dx? So when I have this constant in front, I can move that, or constant before the f of x, I can move that to the front of it, right? And so I can write this as 3, the integral from negative 1 to 1 of f of x dx. And this f of x dx, we said, equals 5. So this actually equals 3 times 5, or 15. Yes. The 3 is right here. It's inside the integral. All I did was take and move it out front.
So really, we didn't even need this first one on negative 1. So why did we not use it for the 1 and 4?
So the bounds here only go from negative 1 to 1. So we had to use the negative 1 to 1 integral to count it. Right, so this 3, technically I moved that 3 out in front of my integral. So now this whole negative 1 to 1 of this all equals 5.
Oh, so you just kind of pulled it
Out to the front. Yeah, that's a rule we can do.
Yeah, but
Go ahead.
you just rolled the 3 down.
Yeah, well, the 3 was in here to begin with.
There, but why wasn't it in this first one?
Let's try another one. Well, let me try example number 2. Maybe I'll clear this up a little better. Okay? Okay. Example number 2. Example number 2. Let's say I have an integral that goes from negative 1 to 2 of f of x dx, and we want that to equal 10. Let's say I have an integral that goes from 2 to 4, sure, of f of x dx, and that equals 12. All right. And I want to put one more in here. Squeeze it down here. Let's do an integral from negative 1 to 2 of g of x dx, and that equals negative 7. No, I kind of squeezed it on the side, but all right. So we have 3 given intervals that are telling you the value of it. So if you're given an integral that has from negative 1 to 2 of f of x, it's going to equal 10. If you're given an integral from 2 to 4, right, it's going to equal 12, exactly. Yep, go ahead, help yourself. All right, so everybody understands the given information I've given up there.
Oh, so it's going to say.
Yeah, it's going to give you integrals that you're going to use, okay, to begin with. All right, so now here's your first question. It's kind of like saying, okay, part A. I want you to evaluate the integral from negative 1 to 4 of f of x dx. We don't have an integral up there that goes from negative 1 to 4, do we?
So you got to combine the 2.
Yes. So we have to do the integral that goes from negative 1 to 2 of f of x dx, and we have to add that to the integral that goes from 2 to 4 of f of x dx. So this integral that goes from negative 1 to 2 equals 10. This integral that goes from 2 to 4 equals 12. So that means this integral that went from negative 1 to 4 equals 22. Exactly.
Oh, so it's like the U.
Huh?
We're basically just writing this down so we can use the number to add them together.
Yes.
So how do we know what property to use?
That's what we're... Yeah, you've got to look at what the integral is set up as and what you need. So let's do this one. We'll do b. All right, so again, I moved my integrals. But let's say I have the integral of negative 1 to 2 of f of x plus g of x dx. So when we were doing our rules, right, we said we could take this and split it into two of them because we had two different functions. So this is the same as the integral from negative 1 to 2 of f of x dx plus the integral from negative 1 to 2 of g of x dx. So from negative 1 to 2, f of x dx equals 10, right? So this one equals 10 plus... Oh, was it negative 7? Thank you. Yeah, sorry. 10 plus the negative 7? Equals 3. All right, so what you're doing today is, honestly, we're working with these and just manipulating them to get them to work out. All right? So it's just kind of like our intro. Now, the only reason that I say there are 6 of them is because, like for number 1, there's A through F.
Oh my God.
You know what I mean? Don't give me that look. All right, so I really want to take the time to make sure we're all understanding. So I'm going to put number 1 up here so we can kind of chit-chat about it a little bit. Number 1. Yeah. I'm going to put them up here from 1 to 2. Yeah, you want to put this on your homework. 1 to 5. Not unless you need help adding negative 4 and 6 together. I know. And 8. So, in this one, we have 3 given intervals. 1 to 2 is negative 4, 1 to 5 is 6, and 1 to 5 of a second, 1 is 8. So, for part A, it looks like this. Nope, because they'll be in your book. I have the integral from 2 to 2 of g of x dx. So, this is the second one we wrote down. This is the 0 property. If my lower bound is 2 and my upper bound is 2, what is the area underneath that curve? 0. It's 0, exactly. That's all it is for part A. It's 0. Part B. For part B, we go from the integral from 5 to negative 1 of... Oh, that's 5. That's a positive one, by the way. It helps if I can read correctly. Sorry. That goes from 5 to 1 of g of x dx. So what's the first thing you have to do in order to get the bounds in the right spot? Got to make a negative and flip it, right? So it goes from 1 to 5 of g of x dx. Negative 8 is the correct answer. All right. C. Put C down here. I'll do one more together. For C, I go from 1 to 2 of 3 f of x dx. So if I have a 3 inside the integral, why negative? Huh? The bounds are still okay, right? Oh, okay. So the 3 is going to go to the outside of the integral from 1 to 2 of f of x dx. So now we're just multiplying 3 times, what is this 1 to 2 of f of x dx equal? Right, so this whole thing equals? Negative 12, I agree. So these are pretty simple, right? It's just a matter of looking at those different rules and working through them. And you guys have like 20 minutes to do it all in. So. Oh, sure, I can do d up there. All right, so let me get d written up here. I have d is the integral from 2 to 5 of f of x dx. So, think about what you have. You have one integral that goes from 1 to 2, and you have one integral that goes from 1 to 5. So, hold on. All right, you guys, hold on. All right. So, what I would do is from this, if I'm going from 2 to 5, I have to first go from 1 to 5. Yeah, and then I want dx and subtract my integral that goes from 1 to 2, right? Is that the other one? Yeah, 1 to 2 of f of x dx. So this integral, right, between the two of them, so 1 to 5 we said was 6, minus 1 to 2 was negative 4. So this just equals 10, okay? So it follows the same property as if you add them, right? It's the additive property. All right, so you guys are good? Okay. See, this isn't a bad day for those guys to miss. This wasn't too bad, right?